Hello everyone. In today's lesson, we will talk about how to solve a system of linear equations by using the substitution method. Now, substitution method is considered to be an algebraic method, and we just learned how to use the graphing method. Now, there is a number of steps we have to follow. I'll go over them as we solve a system together. So here we go. We have a system of two linear equations, y equals x plus 4 and y equals 2 minus x. And step number 1 says that we must solve one of the equations for one of its variables. So it doesn't specify which equation, so it's up to us which one we choose. And I'm going to get started with the first equation here. And we're going to say that y equals x plus 4 is the equation we chose to work with first. We need to solve for one of its variables. I already made my decision. I'll solve for y. And you know why? Because it's already solved for y. Okay? Next step, we have to substitute the result from step 1 into the other equation. So you see the key word in here is substitute. That's why we call it the substitution method, by the way. So what does that mean again? This means that the y value, which equals x plus 4, so if you say y or x plus 4, it means the same thing. So the y value of x plus 4 must be substituted now into the second equation. So it will go in place of this y in here. So we're going to rewrite the second equation, y equals 2 minus x, slightly differently. So y equals 2 minus x, which is the second equation. We'll have y equal to x plus 4. Okay, so this x plus 4 will substitute this y. So we'll write x plus 4. Let me make it pink actually, so it makes more sense. Will equal 2 minus x. So far so good. And as you see here, now we've ended up with a linear equation. So if you look at the next step, it says you have to solve the linear equation that has only one variable, the variable x. And we're going to say, I'm going to group the x terms in one side. So the pink x is already on the left side, so it will stay here. The green negative x from the right side will go to the left side. Switch the sign to positive. We have 2 on the right side. Nothing will change to this term. And positive 4 will travel, move to the right side. It will change the sign to negative. So we are solving this system of equations, which means that we simplify the left side, we simplify the right side, and we solve for x, which is negative 1. We're just dividing by 2, right? So x equals negative 1 will be the coordinate of the x-coordinate of the solution. Now, in order to figure out what the y-coordinate is, we need to take a look at the next step, which says we have to take this answer and substitute it into the other equation. So, which means x equals negative 1 must be substituted into the first equation so we can figure out what the y value is or will be. So y equals x plus 4. We'll change to y equals negative 1 plus 4 or positive 3. So this would be the y-coordinate at the point of intersection or of the solution. So we're going to say that the solution to this equation will be x equals negative 1 and y equals positive 3. And now we might be wondering, well, does this work for both equations? How do we know? It's very easy to prove the solution. The way I like to do it is this. I make a t-chart. You don't have to, okay, but it just keeps things more organized. So the first equation, y equals x plus 4, with the solution of x equals -1 and y equals 3, will change to become y3, -1 plus 4, 3 equals 3, so it works. The equation y equals 2 minus x, we'll have y equals 3, 2 minus -1, 3 equals 3, so both sides are equal, which means the solution works. So -1 and 3 is the solution to the system, and we just solve by substitution. Okay, so let's move on to another example. Remember, the more examples you do or the more you practice, the easier it comes to you, like the solution, and it's going to be easier and faster. You're going to get faster at solving these systems. Here goes the second example. I like to highlight each equation first. This is my first, and this is my second equation. And I will examine both equations. I know that I have to solve one of the equations for one of the variables. And this time, I'm deciding to work with the second equation, and I'll tell you why. Remember that in the first step, we need to solve for one of the variables. And if you look at the second equation, the equation is already solved for y, so we don't have to do any extra work for it. Whereas in the first equation, x needs to be isolated from the negative, y has to be isolated from 3. It would be nothing wrong with choosing the first equation to work with. However, we have to do more work. So we want to work smart in the meantime. Now, once we get the variable y from the second equation, we substitute this y into the first equation. So this y in here, sorry, I meant to do this. So we'll go in place of this y in here. So here we go, -x plus 3y equals 1. I like to write the equation as is first. -x plus 3, so instead of this y here, we are going to write -2x plus 5, because that's what another name for y is in our case. And we'll have -2x plus 5 right here equals 1. See how we ended up with a linear equation? All we have to do is solve for it. So -x, and then remember that we need to expand here. 3 will multiply every term inside the bracket, so -6x plus 15 equals 1. -x minus 6x, -7x plus 15 equals 1. I'm going slow here. -7x equals 1 minus 15. Numbers to the other side. Or -7x is -14. Isolate x from -7 by dividing both sides of the equation by -7, and we get x equals 2. That would be the x coordinate at the point of intersection, or the solution of the system. So we'll take this x, which we got from the first equation, substitute it into the second one. So it's like back and forth with the substitution method. And we're going to say, maybe we'll go this way around. This x of 2 will go right here. And we have y equals -2 times +2. That's what we got for x. Plus 5. So y equals -4 plus 5. Remember bad math, so multiplication first. Y equals 1. So when x equals 2, y equals 1. So we're going to say, well, it seems that we got our solution here. The point with coordinates 2 and 1. Now, if we want to check and see if the solution works for both equations, then we can check the answer. Why not? So the first equation is negative x plus 3y equals 1. So remember, this is x, this is y, so negative 2 plus 3 times 1 equals 1. Negative 2 plus 3 equals 1. 1 equals 1, so we're happy here. And the second equation, y equals negative 2x plus 5. Y is 1, x is 2. 1 equals negative 4 plus 5. 1 equals 1, so 1 satisfies the second equation as well. So we're going to say, yay, we're happy with the solution we found. Now, I would encourage that you try the next example on your own. I will show you the solution in a different video. Have fun and try to go over the steps as we described them in the previous examples while you try to